Today we're going to go over Big Idea 7 Standard 1, Interpreting Heating and Cooling Curves. So here are two pictures. One is a heating curve, one is a cooling curve. So the way that we can tell the difference is that the heating curve, the temperature is going to increase over time. So if we look at the x-axis, it's showing us the amount of heat that is added over time compared to the temperature. So this first one represents the heating curve because temperature is increasing over time. In a cooling curve, temperature decreases over time. Alright, so we can label these boxes on each of our curves. So the first one, at the lowest temperature, our substance is going to be a solid. Next, once we heat that solid up, it can turn into a liquid. And if we continue heating, that liquid becomes a gas. Cooling curve is going to be just the opposite. So up at the highest temperature, our substance is going to be a gas. That gas can cool down into a liquid. And then finally, that liquid can cool and become a solid. So anytime that we have these diagonals, anytime that we have a change in temperature, this also is going to represent a change in kinetic energy. So kinetic energy, kinetic sounds like movement. Anytime I have a change in kinetic energy, I have a change in temperature. So what happens is as our temperature increases, the molecules move faster, and therefore the kinetic energy is going to increase as well. The plateaus are these flat portions. So the plateaus, start with P, they are going to represent a change in potential energy, which is our stored energy. And they're also going to represent a phase change. So plateaus are a change in potential energy, but they're also representing a phase change. A phase change just means we have a change in state of matter. So we have 4 phase changes. If we are changing from a solid to a liquid, we call that melting. I'm going to call this segment A. So the substance is melting when it's changing from a solid to a liquid. When it's going from a liquid to a gas, we can either say that it's boiling or evaporating. So segment B is going to represent boiling or evaporating. Our cooling phase changes. If a liquid cools into a solid, we call that freezing. So that plateau between a liquid and solid is going to be freezing. And then if a gas is cooling into a liquid, we call that condensation or condensing. So that segment D would be condensing. Anytime we have a plateau, we're going to have a mixture of 2 states of matter. So if we look at this plateau where it's melting, right here, the substance is going to be 100% solid. And by the time we get to the end of that segment, it's going to be 100% liquid. But when we are like in the middle of this segment, we are going to have a mix of both solid and liquid. Think about when an ice cube melts. During that process of melting, you have a mixture of both solid ice and liquid water. So that plateau is representing that mixture of those 2 states of matter. Alright, let's look at 2 examples. So first, you should be able to look at a curve and determine, is it a heating or cooling curve? So if I look at this curve, as time goes by or as energy is either added or released, we see that the temperature is decreasing. So this is going to be a cooling curve. Next, is the cooling curve endothermic or exothermic? So if it's endothermic, energy is entering the system. If it's exothermic, energy is exiting the system. So in order for a substance to cool down, it needs to lose heat energy. So energy is going to have to exit or be released. Cooling curves are always going to be exothermic. All right, next, you should be able to label some stuff on your curve. So at the highest temperature, the substance is going to be a gas. So segment AB, it's going to be a gas. From C to D, it is a liquid. And E to F, the substance is a gas. Next, we should be able to label where we have a change in kinetic energy. So anytime we have a temperature change, we have a change in kinetic energy. So all of those diagonals are going to be my changes in kinetic energy. All right, remember everything that starts with the letter P goes together. So we are going to have a potential energy change when we have a plateau, which is just those horizontal flat portions. All right, and then lastly, we should label each phase change by its name. So again, everything that starts with P goes together: plateau, potential, phase change. So segment BC is going to be a phase change where a gas is cooling into a liquid. So that is going to be condensing. And then I also have another phase change between segment DE. The liquid is cooling into a gas, so that would be freezing. All right, example 2. Some of the same questions, but we have some new questions. So first, what type of curve is this going to be? So I see that at point A, my temperature is -50, but up at point F, my temperature is 75 degrees Celsius. So temperature is increasing over time, so this is a heating curve. If we want a substance to heat up, heat has to enter the system. So this would be endothermic. All right, at the coolest temperature, it is going to be a solid. That solid is going to melt into a liquid. And then that liquid is going to boil into a gas. So again, whether it's a heating curve or cooling curve, you should be able to label where is it a solid, liquid, gas in each phase change. All right, next question. Sometimes a tricky question for students. What is the freezing temperature? So the melting point is going to be equal to the freezing point. These two phase changes will always occur at the same temperature. So I see that the melting point is a -15 degrees Celsius. That means the freezing temperature is also -15 degrees Celsius. It takes the same amount of energy for a substance to freeze as it does to melt. So let's say I need to put in 100 joules of energy to get my substance to melt. Well, if I remove those 100 joules of heat energy, that substance will freeze. So since it takes the same amount of energy, they're going to occur at the same temperature. This is also true for boiling and condensing. Boiling and condensing are always going to occur at the same temperature because they take the same amount of energy. So this substance boils at 60 degrees Celsius. The condensation temperature would also be 60 degrees Celsius. Next question. At what point does the liquid begin to increase in temperature? So all the way from C to D, my substance is a liquid, and it's increasing in temperature over that whole segment. But the key word here is begin. It begins to increase in temperature at point C. Right here is the first place that that liquid begins to increase in temperature. Last question. Where is the substance both a solid and a liquid? Where do we have a mixture of both? Well, this is going to be segment BC. So from A to B, the substance is a solid. Once we hit point B, it is going to start to melt. But in here, it is going to be a mixture of both. All right, and that is it for interpreting and labeling heating and cooling curves.